Hi everyone, welcome to this module A, the Internet Protocol. In the first point is purpose of an IPv4 address. The IPv4 address. A host needs an IPv4 address to participate on the Internet and almost all lands today. The IPv4 address is a logical network address that identifies a particular host. It must be properly configured and unique within the LAN for local communication. It must also be properly configured and unique in the world for remote connections or communication. This is how a host is able to communicate with other devices on the Internet. An IPv4 address is a signal to the network interface connection for a host. This connection is usually a network interface card installed in the device. Examples of end-users devices with network interface include workstations, servers, network printers, and IP phones. Some servers can have more than one NIC card. Each of these has its own IPv4 address. Router interface that provide connection to IP network will also have an IPv4 address. Every packet sent across the Internet has a source and destination IPv4 address. This information is required by networking device to ensure the information gets to the destination and any replies are returned to the source. In this image we can see how this user is sent a packet with this IP address across the internet and arrive to the server with this IP address and return a message. In the next point is octet and dotted decimal notation. IPv4 addresses are 32 bits in length or is an IPv4 address in binary. This is very important. IPv4 addresses are 32 bits in length. Notice how difficult its addresses is to read. Imagine having to configure a device with a series of 32 bytes. For this reason, the 32 bits are grouped into 4 8 bytes called octets like this. Okay, his IPv4 addresses are 32 bits in length, and the 32 bits are grouped into 4 8 bits. Bit bytes are called octets like this. Okay, that's better, but still difficult to read. That's why we convert each octet into its decimal values, separated by a decimal point or period. The above binary IPv4 becomes this dotted decimal representation: 201.178.200 and .1. Note: for now, you do not need to know how to convert between binary and decimal number system. And we have a packet tracer activity. This is for the next. I continue with the next point is the IPv4 address structure. Okay. Network and host. The logical 32 bits IPv4 address is hierarchical and is made up of two parts: the network and the host. In the figure, the network portion is blue and the host portion is red. Both parts are required in the IPv4 address. Both networks have the subnet mask. The subnet mask the subnet mask is used to identify the network on which the host is connected. The subnet mask is used to identify the network on which the host is connected. As an example, there is a host with an IPv4 address 192.178.5.11 with a subnet mask. The first three octets 192.178.5 identify the network portion of the address, and the last octet 11 identifies the host. This is known as hierarchical addressing. because the network portion indicates the network on which each unique host address is located. Routers only need to know how to reach each network, rather than needing to know the location on each individual host. With IPv4 addressing, multiple logical networks can exist on one physical network if the network portion of the logical network host addresses is different. For example, three hosts on a single physical local network have the same network portion of their IPv4 address, 192.178.18, and three other hosts has difference between portion of their IPv4 addresses, 192.178.5. The hosts with the same network number in their IPv4 addresses will be able to communicate with each other, but will not be able to communicate with the other host without the use of routing. In this example, there is one physical network and two logical IPv4 networks. Another example of a hierarchical network is the telephone system, with a telephone number, the country code, area code, and exchange representing the network address, and the remaining digits represent a logical phone number. And we can see a router and switch, three PCs, uh, network number in blue, network number in green, and the host number in red. Finish with this quiz. Question: what host A as the IPv4 address and subnet mask? What is the network address of host A? Okay. What is the network address? The network address is this 10.5.4. Okay. That's right, the network address with the subnet mask is okay. Question 2. Host A has the IPv4 address and subnet mask. This and what is the network address of host A? It's the same, but in this case, this is the network address 172.16.4. Okay. Okay, sorry. Is this reset? Okay, sorry, reset. Is 172. Dot. Okay. Okay, I don't know what is. The network address with a subnet mask. Okay. The next is host A has the IPv4 address and subnet mask. Which of the following IPv4 address will be on the same network as host A? Host A has the IPv4 address and subnet mask. Which of the following IPv4 addresses will be on the same network as 10.5.4? Choice all that apply. Okay, that's right. And question 4. Host A has the IPv4 address and subnet mask. Which of the following IPv4 addresses will be on the same network as host A? Okay. Okay, sorry, reset. That's right. Okay. And question 5, host A has the IPv4 address and subnet mask. Which of the following IPv4 addresses will be on the same network as host A? Choice all the W. Okay, that's right. Okay. And finish with the Internet Protocol summary. What did I learn in this module? The IPv4 address is a logical network address that identifies a particular host. It must be properly configured and unique within the LAN for local communication. It must also be properly configured and unique in the world for remote communication. An IPv4 address is assigned to the network interface connection for a host. This connection is usually a NIC installed in the device. Every packet sent across the Internet has source and destination IPv4 address. This information is required by networking devices to ensure the information gets to the destination and any replies are returned to the source. And the IPv4 addresses structure, the logical 32 bits IPv4 address is hierarchical and is made up of two parts, the network and the host. As an example, there is a host with an IPv4 address 192.178.5.11 with a subnet mask. The first three octets identify the network portion of the address, and the last octet 11 identify the host. This is known as hierarchical addressing because the network portion indicates the network on which each unique host address is located. Routers only need to know how to reach each network rather than needing to know the local of each individual host. With IPv4 addressing, multiple logical networks can exist on one physical network if the network portion of the logical network host addresses is different. Webster reflection question. It makes sense that every device on the network has an IP address, and routers use these addresses to send packets from the source to the destination. When I send a letter through the mail, I put my address and the address of the recipient of the envelope. But now I see the other connections to how network operate. The postal code and serial of my recipient is a little bit like the network portion of the IP address, and the street address is like the host portion of the IP address. Can you think of any other analogies of the network operation and IP addresses? Finish with the Internet Protocol quiz. Question what criteria must be followed in the design of IPv4 addressing scheme for end devices? Each IP address must match the address that is assigned to the host by DNS. No. Each IP address must be unique within the local network. Yes. No. Question 2. How many octets exist in an IPv4 address? This 4. Question 3. Which two parts are components of an IPv4 address? That is network portion and host portion. Question 4. What is the purpose of the subnet mask in conjunction with the IPv address? To uniquely identify a host in a network, to identify whether the address is public or private, to determine the subnet to which the host belongs, to determine the subnet. A technician is setting up equipment on a network. Which three devices will need IP addresses? Choice 3. A printer, a server, an IP phone. Question 6. Which statement describes the relationship on a physical network and logical IPv4 addresses networks? A logical physical network supports one IPv4 logical network. A physical network can connect multiple devices of different IPv4 logical network. All devices connected to a physical network need to belong to the same IPv4 And devices on different IPv4 logical networks can communicate with each other if they are connected to the same switch. Okay. A local physical network support one IPv4 logical network. A physical network can connect multiple devices of different IPv4. Okay. Question 7. How large are IPv4 addresses? 32 bits. Question A. What is the network number for an IPv4 address with the subnet mask? Is this 172.17 and .4? Question 9. What are two features of IPv4 addresses? An IPv4 addresses contain 8 octets. An IPv4 is a logical addressing scheme. An IPv4 addressing scheme is hierarchical, and an IPv4 address are only used for communicating on the internet. IPv4 address is bound to network interface card to make it unique. No. Okay. I don't know what is. I think it's this, but I don't remember. IPv4 is a logical addressing scheme. Yeah. And question 10. Consider the group of 5 IPv4 addresses, each with a subnet mask, which two IPv4 addresses belong to the same local network. Choice 2. Okay. Is this question 11? The IT group needs to design and deploy IPv4 network connectivity in a new high school computer lab. The network design requires multiple logical network be deployed by deployer on one physical network. Which technology is required to enable computers on different logical networks to communicate with each other? This is the routing. And 100% score. Congratulations, you have passed the tests. Perfect. Okay. Okay, this is all for this Internet Protocol module. See you in the next one. Bye.